Copyright in these lectures is either owned by the ANU or a third party who has licensed the ANU to use it. Students may use the recording for personal study only. No lecture may be communicated online, copied or shared without the prior permission of the ANU.
Technology component. It's gone so fast this semester already.
It is amazing. In the break. Well, ladies and gentlemen, can you hear? Yes, you can hear. Can you see? There should be a screen here, shouldn't there? Can you see some screens? Near enough? Well, welcome to the new world. World of fresh air, sunshine, having chairs for you instead of you having to get your own, not having to be here first. It's a great world. And sitting in your teams, isn't that good? Excellent. This is a good way of getting assignment 2 well and truly completed. Well, I came and investigated this space before the class, of course, to see if it was going to work for us. What I didn't bring was my remote slide changer. So I'm going to have to stand over in the corner and talk to you from there. So this is what we're going to do today. We're going to have a couple of short bursts on technology and organisations, the way technology and organisations get together. So we're stepping back a bit from what we've been doing, which is hardcore assignments 1 and 2, which is all about concepts and looking at an ICT topic conceptually and in detail, and assignment 2, which is all about an application in the real world, in Kangaroo Island, of ICT and its various components and the way it's put together. So today we're just going to stand back and have a bit of a broader look. So I'm hoping that these talks won't go for very long and that we have time then to work on assignment 2, or you can talk to me about the last part of assignment 1 that you've been playing with. I've had quite a lot of people sending me questions, most of which I put up on the discussion forum. Those discussion forum posts will help you with some of your questions about formatting and referencing and all that sort of stuff. So have a look at those, and if you've still got a question, then I'll be here to talk with you about them. So as normal, we'll start off by, having a quick look at where we're going and where we've been. So these are our 6 modules, and we're here at module number 5, organisations. And we've talked about architecture, we've talked about conceptual modelling of data, conceptual modelling of processes. We've talked about systems and subsystems and causal loops and so on, things that make systems tick. Organisations today, and then next week we'll have a quick look at ICT futures and some other topics like ICT ethics and things. So assignment 1. Most of the knowledge you needed for assignment 1 was in the first 3 weeks. They fed into that. And assignment 2, well, it's been feeding in from the very beginning right to the very end. And we'll have an exam, which I'll talk a bit about next week. Read the discussion forums. So, thinking about assignment 1. In week 2, we looked at conceptual frameworks, analysing concepts and building conceptual frameworks. And we've talked about this every week since then, because this is a key intellectual skill for you to develop, not just for thinking about IT, but for thinking about any subject that you do at the university, or thinking about anything that you do in professional and personal life. Concept analysis is the key to being objective about some situation. What we talked about was a method which was looking in the literature of various kinds for descriptions of the concept you're interested in, looking for definitions, for how it's used in practice, and for starting to decide on what the scope of your assignment work is, or what the scope of your thinking is going to be, by excluding some of the things that are irrelevant and focusing on some of the things that are important to you. And always write. Never read without your keyboard underneath your fingertips. You can't just read and expect it all to go into your mind and stay there. It doesn't work like that. And one student actually sent me a note saying, I want to change my topic because I've read all this stuff and put it all in my mind and I still can't make much sense of it, so I want to change my topic. Well, of course you can't make much sense of it. You haven't done the actual hard work of writing it down as you go and building, analysing, putting things back together again. You can't do this in your head. It just isn't. A machine can, but you can't. You're a human. You've got to actually do it bit by bit, and you've got to iterate and go over it and over it and over it, reorganising it, deepening some parts, losing other parts. This is the way that you build up a solid conceptual framework. And it's the way you do any assignment of any value. The idea that you can stick it into your head and it's there, you can forget that. That's school stuff. That's rote learning stuff. So, always have your keyboard under your fingertips whenever you're reading and write. If what you're reading looks halfway interesting, take down the reference. That way you won't accidentally plagiarise. Then, identify the attributes of the concept so that you can tell a concept when you see one. Look for examples of the concept that you're thinking of or doing some analysis on. And we've talked a little bit about hard and fuzzy concepts. Hard concepts are those that are defined by their boundaries. So, for example, you're a student because you have a student ID. Somebody that doesn't have a student ID is not a student. That's a hard boundary. That concept of student is really hard. You're either one or you're not. But the other kind is fuzzy concepts, and these are the ones which have a central core, a basic idea, but they fade away as you get further and further away from the core. So you might have what we talked about, grapevines at one point being in a particular stage of growth, and there's a long lead up to that stage and a long phasing out after that stage is over. So the grapevine's only in that stage for that very small amount of time right in the middle. So the fuzziness is how much of it is in that stage. So keep an eye open for whether the concepts you're dealing with are hard or fuzzy concepts. And if you've got a problem, if you come across an example that's hard to classify, then it's highly likely that your classification is incorrect or doesn't suit the way the world actually is. So you've got to change it. You've got to change your definitions or change your ideas about what this concept covers and what it doesn't. Concepts are malleable, you know, they are changeable. You can push them into different shapes. You can make them do things for you. Another student wrote to me saying, look, just tell me what this is. And there is no answer to that, because a concept in your mind has been built by your own experience. And a concept in the public domain, in discussion in books and papers, is built through some social experience, through people interacting and writing and talking about things. Now, it's a social construction. It's neither right nor wrong. It is just a construction, a way of thinking about something. So, what can I say? No, there isn't a right answer to this. There's a matter of doing the research and finding out what people who are interested in what you are interested in are saying, and then using that knowledge. And there'll be lots of disagreements. People will simply disagree with some things. And so once we've been working on one topic, you start finding the related topics, the things around it. And there are a couple of ways of doing this. We've talked about taxonomies, which is looking for what makes up this concept, so analysing it, breaking it into bits. What are the childs of this concept and what are their kids? Building up a taxonomy. And another way is looking for other relationships, which I've called here facets, the facet of the concept, which is things like the use of the concept, the history of the concept, the components in the concept. So there's two different ways of looking at analysing a concept or finding the relations of one concept with others, is to look for the hierarchy, what's the parent and what are all the kids. That's one way. And another additional way is to look for those different aspects or facets of the topic that's being discussed. So it's not a taxonomic relationship, it's a different kind of relationship, often called facets. Now I think the sample of assignment 1 had a few of those in it. You might have talked a little bit about the history of ethics and a little bit about ethics in different places or whatever. And here's your concept map. So I mentioned the concept map up here, building the concept map as you go. It's not just references, it's building up what you are thinking about, putting it down on paper, and then enhance your concept map with these and go back to step 1, using the related concepts. So start unpacking the other concepts that you're finding. What do you actually mean by history? Unpack that a little bit. Figure out what you actually understand by components. What are components? How do they interact themselves? So once you've got your core concept, you've done all this work to start figuring out what it might be like. Now you've put lots of other concepts around it and below it. Now you're focusing on some of those, expanding out or contracting until you get this nice little network. And from that you can do absolutely anything. You can write a linear paper, or you can write a textbook with lots of different chapters in it. You can do anything you like once you've got this reliable, solid core. And I've used this example of a concept map as a way of building one of these things. A number of you used some concept mapping software in your draft assignment 1, which is a great thing to use. So if you just go and do a bit of a Google on concept mapping software, you'll find lots of ways of doing it electronically rather than manually. All right. The other big idea from week 1 was this one. It was starting to build our whole concept of what an ICT system is and its layers. So down the bottom, the very physical layer. Then you've got the physical, technical architecture of sensors and processors, input and output devices. Next layer up is the content layer, which is the actual data, documents and information, the actual software code. The next layer up is the conceptual architecture, where we actually do our designs for metadata. And the top layer is the rich picture, and last week, the causal loop diagrams. So this is the architecture for an information system, starting off with the real world and going right up to the users and how the system works internally. So that was assignment 2, and we got to this point at week 3 roughly. So that's where we're up to, and now we'll have a quick look at a couple of ideas about technology change. So the first of these little theories about technology change, and I've selected these pretty much at random, is Moore's law. And Moore came up with this perception over a very short period of time in Intel, which is the manufacturer of chips. This is a very long time ago. He came up with this idea that actually what happens is that the chip is doubling in power and halving in price. And he mapped this for a short period of time, and he published this and said, "Okay, guess what's happening with technology? It's doubling in capacity and halving in price." And people said, "Oh yeah, excellent, we'll call it Moore's law." And ever since, people have been talking about Moore's law. Well, it doesn't hold, of course. It doesn't apply to all technology. It doesn't apply to all times. But it's a good indicator of something that has been happening. It's much more sporadic than that. You get these big leaps. So when flash drives, flash memory went into production and disrupted IT, you had this huge leap in storage capacity that was available. And that made a dramatic change to both the price and to the capacity of computing over the period of a year. So Moore's law doesn't hold, but it shows a tendency. This tendency that things continue to get more powerful and less expensive as time goes by. Those of you doing Internet of Things will have found some interesting aspects of Moore's law, maybe. Technology diffusion. The idea behind diffusion is that technology has a life. That is, it is triggered off at one point when it's invented and when it starts to be built, and sometime later, if it's adopted, it will be absolutely everywhere. Take the mobile phone, for example, which started off very small because it needed infrastructure, it needed towers in order to work and so on. Small patches innovated and got this mobile technology, this cell technology actually operating. Innovators and early adopters jumped on this and said we can do it here and still make money out of adopting this change. And then it took off like wildfire. Because after you get a small amount of adoption, the price comes down and off she goes. And that's what happened with mobile phones. Over the 20 years, we've gone from these strange shoebox type phones about this big with an aerial sticking out the top to tiny phones that do remarkable things, things that computers of 20 years ago could go nowhere near. And the blue graph shows early adopters and then the majority adopting it and then the laggards coming on board later on because if they don't, they're out of business. So the idea is that technology diffuses, and there's a lot of writing about what helps it to diffuse and what inhibits that. Technology acceptance. This is another theory around technology, about its acceptance by people. What this diagram says is that the boxes refer to, or the outside boxes refer to factors that influence the intention of somebody to act and what they actually do. So the outside factors, things like gender, age and experience, they affect people's intention to take on a new technology, to accept a new technology. And and if you can measure all of those effects and those variables, then you should be able to predict intention and behaviour. That's what the theory says, that these are causal predictions. And this idea of technology acceptance has been tested over and over again for the last 20-odd years. The guy who initiated it, Venkatesh, is a regular visitor to ANU. So it's kind of interesting. I have no time for it myself because there have been many studies that demonstrate that it accounts for a very small part of the intention of people to adopt technology. And one of the problems with technology is, in organisations, is that management decides whether it'll be adopted or not, and people simply have to take it or leave it. So it's not the case that you have all of these factors influencing it. I also get a bit cranky when people say that old people can't use technology and that age is a barrier for adoption. That makes me cranky because I'm an old person and I quite like this stuff. And lastly, or almost lastly, the Gartner hype cycle. Now, Gartner is an important research organisation in technologies. Gartner reports are very reliable. They're as reliable as government reports. So if you see reports from Gartner, you will be on safe territory. What Gartner said was, or what they thought was, there's a technology trigger, and then people say, this is going to be great. And so there's this great hype about a particular technology, and lots of people go and buy it and start using it. And then they realise, actually, it isn't that good. It's got bugs in it, and I thought it was going to do this, but it doesn't do this. And the population sinks into this trough of disillusionment. But then it starts to figure out, well, actually it's not that bad because I can use it for this and this. And so they start feeling better about it, and eventually it's used more productively. So it settles to a comfortable kind of a usage. They say this is the hype cycle. And the last idea is technology push and pull. You won't be able to read this text, but it's there on the slide for later reference. The principle is that technologies can be developed because there is a need for these technologies. Somebody detects a need, and so they go and build something that will meet the need. That's technology pull. And technology push is where somebody says, I've got a good idea for a bit of tech. I'll build it and see where I can push it into the world. And that's technology push. Push and pull. So organisations are generally about technology pull because they've got a problem and they look for technological solutions to pull in. But innovative organisations are also looking for opportunities. So they're scanning for tech that's being developed, push type tech, so that they can try and jump on it and become an early adopter. So looking for opportunities. So it's problem solving versus taking advantage of something that's going on. Both solid and effective management strategies. What this text is talking, this text comes from a particular academic paper, and this paper was talking about changes in transportation. And I just put that up there because the paper contains a model that looks like this. This model has 4 major sections, and it's about transition from fossil fuels to renewable energy at the top. That's one of the drivers. Increasing autonomy of vehicles. That's another big driver on the right. Down the bottom, increasing urban density. And over to the left, the rise of the sharing economy. So these are 4 major trends that are actually happening, some of them sociological, some of them technical. And this paper tries to identify what those trends are and how they are affecting each other. So the intersecting Venn diagrams says that this factor down the bottom in whatever colour that is, mauve, and the blue affect each other this way, and it links with the other 2 that way, and all together we come up with things that are happening at the intersection of all 4 of these trends. So what this is doing is some forecasting about how these trends might be responded to by government if it was taking an interest in them. It's an interesting paper, might be worthwhile looking up. So what we're talking about here is various ideas about technology, theories about technology generally. And the last one is disruptive technologies. Now we hear a lot about disruptive technologies. Uber was a disruptive technology. But what was new about Uber when it was implemented? Was it the cars? No, nothing different about Uber cars. They're just cars with drivers, just like taxis. So it wasn't the cars. Was it the website? Was it the fact that you had GIS to show you where cars were? Oh, nothing new about that. So what was it about Uber? Well, it was bringing these things together into a system, an economic system which gave benefits to people who wanted to drive their cars and pick up passengers and things. So they provide the platform with an app, and the drivers came on board, and boom, you had a new system running. It wasn't a new technological system, it was a new human system, human activity system. And it was disruptive because it broke up the taxi industry. So the taxi industry had a monopoly, and it was run in a particular way under government regulation. And then this system arose, like Airbnb, arose on an information technology platform, plus all of the human systems around it to make it compete with some existing marketplace. So it was disruptive because it had a huge effect on the market. Not all technology changes are disruptive. A lot of technology changes are evolutionary. That is, they just do what's being done at the moment, only they do it better or quicker or with fewer people or with greater engagement of customers and stakeholders and whatever. So they may be evolutionary. And you may get some radical change, but it's not called disruption until it actually makes a big change to the way the world works. So disruptive technology is not a piece of technology, it's about systems changes. So there's a few ideas about theories of tech change. So now I'm just going to talk a little bit about organisation, because this is basically about technologies and organisations and how they interact. So let's, having had a look at technology, have a look at some organisational theories. And I imagine you're coming across these in some of your other courses. So firstly, a trajectory of management theory from the early days, where it was all about, well, it comes basically from the military, really. It was all about serious control, scientific management, which is production lines, and reducing all of what an organisation does to very small tasks that can be done by somebody without much skill or training, and certainly no initiative, separating out the operations of an organisation from its management and strategy. And then into the neoclassical period, which was much more about humans and about human resources, and looked for the behaviours of things rather than for the strict organisation of things. And now into what they call modern management, which is basically systems, the application of systems thinking to management, and a bunch of other things, the references at the bottom. Here is a list of organisational theories associated with that trajectory of management theory. The ones in red are the ones that we'll talk briefly about. So we've talked about technology. This is a list that comes from the Food and Agriculture Association. We've talked a bit about technology theory. We've talked about systems theory last week a bit, so we're just going to have a quick look at organisational structure and maturity, and those other aspects I'll leave for your management subjects, because they're not specifically related to technology. So let's have a look at these ideas of organisational structure and maturity. If we look at an organisation as a system using the three worlds model, we'll find that the human system embraces all of these worlds, well, pretty clearly. If you take ANU as a human system, it's quite large, you know. It's got lots of World 1 things in it. Like we are sitting in one of these buildings, which is World 1. Sitting at your desk, you've got a chair, you've got blah, blah, blah. Lots of World 1 stuff. But that doesn't make ANU. That's just physical stuff. There's lots of World 2 stuff. There's heaps of academics. Not enough probably, but heaps of academics, heaps of students, lots of administrators and managers, and all of those minds are active there in World 2. They're all thinking some of the time. And in World 3, we've got all of this administrative procedures, we've got all of the policies, we've got all of the data and information and knowledge that allows us to come to this place rather than in CBE where we were last week. All of this information and data and knowledge is there stored in World 3. And all of these things are brought into a system that actually operates, a human system. And within the system there is some sort of technology system, an ICT system sitting down in the middle of it somewhere that we're often talking with. So organisations are often seen as socio-technical organisations, that is, a mixture of human and technical components, all neatly systematised. This is a chart we saw last week where we were talking about states of things. A very common tool for managing an organisation is to recognise the organisation as a system and then to try and manage it by deriving indicators, matching them with our key performance indicators. And computing is used a lot in order to measure those indicators and to do the matching sort of work. Organisational maturity. The idea with maturity is that an organisation has a life. It starts off, it's born at some point, created at some point, and it goes through a number of different phases. And it can iterate through these phases. That is, it can take a few steps back and go on again. It's not maturity in the sense of getting better and better in a linear form, as this diagram says. The idea is that, let's take a startup, for example. Startup, 3 people start up a little organisation. Let's call it Apple. or Microsoft. Start up this organisation. They're in a garage there in Silicon Valley, and they've got a few ideas, they've got some equipment, they start putting things together. They find that they need some more people, so they get a few more people. Now they've got 7 people working, the garage is too small, so they've actually got to move to a different place, and they realise that they're starting to get in each other's way. So they've got to move to a different way of working. So there's a crisis of some sort, and they move into phase 2. This is the idea, that if you're in a particular phase, you may well find that what you're doing is no longer suitable because you've grown a bit too much, and so you adopt some different management strategy. And then the same thing happens with all of the other phases. And the organisation size is up the side there, and when the organisation gets really big, that's when you've got to think about breaking the organisation up into bits, or have it broken up for you by the government, as the Americans did with the Bell Telephone Company. Breaking up into bits, or trying to find some other way of managing this complexity. This has been neatly synthesised by the CMMI, which stands for the Capability Maturity Management Index. And they've recognised 5 different levels, and at each of these levels they've got a nice clear specification of what an organisation is like that is at this level. And the reason that's useful is that if you're at one of those levels, there's only 2 places you can go. We know from our state transition diagram that if you're in a particular state, there are ways to move. So if you're in level 3, you can either go up 1 or you can drop down 1. That's all you can do, or you can go out of business and disappear altogether. It's quite an interesting approach. The CMMI is, as I say, very well specified, and it's used to analyse an organisation's situation in order to predict what they're going to do next. So I've mentioned management levels, and here's an example of a management level pyramid. Up the side, you've got workers, middle managers, senior managers, and executives. You remember from our systems that we have transaction processing systems that work at the bottom. We've got management information systems that provide information and data to middle managers. We've got decision support systems that are used by senior managers, and executive information systems used by top managers. So there are systems, different sorts of subsystems that operate for these different levels of management. Now there are 2 ways that these management levels cause organisational action. The first is through operations. That's this bit. And all of the lower parts of the organisation are basically doing operations work. And the characteristics of operations are that it's pretty frozen and it's pretty stable. People know what they're doing, they know what they're supposed to do. It's day-to-day business. Doing things right. The other form of organisational action is through projects. The idea of a project is that we have some operating system. What we want to do is unfreeze that system, make a change, and then refreeze it, put it back in its place. So all of the next module in this course, the project management module, will tackle projects and how to manage them. So the project I've been mostly involved with in the last few years is just reached this stage of refreezing. And what we've done is we've changed the way that universities are accredited, the way their courses are accredited. And that caused so much strife because it was a solid system, it had been working for a long time. It had things that were clearly wrong with it, and it had some foundations that were very unreliable. So we tackled the foundations and rebuilt those. We tackled the operational work for the professional society, the ACS, Australian Computer Society, and then we had to get this whole new framework in place. which meant unfreezing, chucking lots of stuff away, bringing in the new structure, training up the people, and then putting it into action. So 1st of January it went live, and so we worked with it and worked with it and worked with it for 6 months, evaluated what was going on, where we were actually winning and where there were problems, put into place some additional training, and then had another total release of the foundational work that went underneath it because we found some flaws. The second release came out last week. So last week marks the refreezing of this quite complex system. Good. So, management levels and the way organisations act. Now, organisations, when they start to get anything other than really small, divide themselves up into divisions or sections. They specialise some of the tasks to be done. So on this diagram, it says that there's a director of some section that looks after program operations, management and administrative programs, and policy and planning. So this organisation decided to split itself up into these 3 different silos, as they're called, because they look like grain silos. And the interesting thing about silos is that they don't talk crossways, they only talk up through the top. So that's the characteristic of siloed organisations. This is the problem that information technology and systems gives to siloed organisations. Here are a bunch of silos, a business that has customer service and it's got transport, human resources, and lots of different silos, all connected through their management to the executive level, but not talking to each other. But when we put in information systems, we do cut across these silos. The information system has to work right across the organisation. Typically it has a database that's used by lots of subsystems within these different silos. And this presents a problem because it comes in from the side instead of through the top. The reporting is no longer flowing up to the business, it's going sideways. And this has caused all sorts of very odd problems within organisations that are invested in technology. Some of the responses have been to totally take apart our siloed organisation and replace it with something else. And that's where you get this idea of customer-focused organisations from, where you have everything focused on a particular customer. But more commonly, you get matrix organisations with some functions down the side and some structures across the top. And people fit in this matrix, reporting to 2 different bosses. That's another option. Not very good, really. So organisations had this problem of the IT people and the systems people cutting across all of these different divisions. Nobody knew who owned these blue dots or who was responsible for their lines that flow through them. So what siloed organisations did was they solved this problem. They invented another silo called ICT, the ICT division. And this silo now sits alongside all of the others, so any organisational diagram you'll see, if you have a look at the ANU organisation, you'll see the various faculties, that's the teaching part, you'll see the various operational silos, that's the administrative part, and one of those will be ICT. It's now a division. This is a diagram of a typical ICT division. Over to the left it's got information centres, ICT technical support, which looks after all of the kit, operations, makes sure that everything's running all right, does the reviews of infrastructure usage. The ICT services, that is providing project management services and so on. Looking after the infrastructure, looking after design and planning. Up the top, looking after ICT security. And that's just a typical organisation chart for an ICT division, a silo within an organisation. Cool. Well, we've certainly skipped through that. questions or statements? Is any of this useful in Kangaroo Island, do you think? Is the energy information management system, is that a bit of hype, or is it a mature technology? Is Kangaroo Island Council in a position where it can actually adopt some smart technology, or does it need to do some maturity? Does it need to get up to another level of maturity before it's actually able to adopt the systems you're thinking about? If Moore's law is right, then maybe they should wait for a couple of years, because then it'll be much cheaper and be much more powerful. So a few possible pointers there that you might consider in the last part of your assignment too, about whether Kangaroo Island is ready for the work that you're doing. Okay, so I'm going to just push on if that's all right, and we'll cover another little area of knowledge, which is, we've talked a bit about IT, we've talked a bit about organisations, and now I just want to talk about the shape of the ICT profession and the knowledge that's in it, and the shape of the ICT discipline, that is the academic area that does research and education in ICT. So firstly, the shape of the skills that you might find in one of those ICT divisions. The skills that are required in a large organisation to make their ICT operate. These skills have been defined in the Skills Framework for the Information Age, SFIA, SFIA. So this is a specification of skills and levels within organisation at which those skills are operating. There is another framework called ECF. This is a UK framework, the United Kingdom. ECF comes from Europe, and it's probably a better one, but this is the one that we used in the project I just mentioned for telling whether or not a computing course being run by a university is going to be accredited as a professional course. We use SFIA to determine whether or not that course has in it education about these various skills. Now, SFIA is quite large. I've taken one very small part from the top of SFIA, just to give you an idea of what it looks like. But it might be worthwhile having a look at the SFIA website and just getting a grip on how large the ICT industry actually is and what people do in it. So this is the strategy and architecture part of SFIA, and it's got information strategy, advice and guidance, business strategy and planning. Across the top are the various levels at which a person might be acting. So level 7 is very high level executive work. Level 1 is very low level entry type work. And the reason why some of these don't start until they're quite high is that we're talking about strategy and executive skills here. So the long ones are the ones that are where people start on this business, and the top ones are the professionals. If you look at programming as a skill, you'll find that it is only in levels 1, 2 and 3. As you scroll down, some skills are quite low in the levels, and other skills like this quite high. Here are the 7 SFIA levels and the sorts of jobs that you would expect those people to have. So down the bottom, level 3 and 4, is your apps programmer, your support people, and so on. Right at the top is the Chief Information Officer, and for some reason they put academics up there as well. Just never understood that. Anyway, got the Chief Information Officer at the top, and in between these different levels of skill and the different sorts of work that people do. So there's Sophia 5 in the middle, the business analyst, the various engineers, the cybersecurity specialist, and the information architect. And some of you are doing assignment 1, you're tackling the actual concept around cybersecurity or whatever, and those are the sorts of jobs, that's the sort of level of role that the people you've been thinking about, or the knowledge you've been thinking about, would actually be using. So that's the shape of the industry. So now we've got an idea of the ICT division having lots of different components in it, in a silo, and now the people that are actually acting in those silos, this is specification of their skills and the roles that they play. So what I'm trying to do here is simply to cover the ideas about what the shape of the ICT industry is. Now, accompanying the idea about ICT skills is the idea of generic skills. That is, the skills that you need personally in order to be able to operate in an organisation. And these are called the core body of knowledge in the Australian Computer Society. And those essential skills are, just going down from the top, professional knowledge. That is, knowing how a professional actually behaves rather than behaving purely as an individual with your own likes and dislikes that are at the surface. A professional behaves in a professional manner. The second level is the code of ethics. That is, what does an ICT professional need to know about ethics and about how it plays out in their professional work? And we'll tackle that next week. An ICT professional needs to understand project management and be good at it. An ICT professional needs to know about security and about the kind of legal constraints on what ICT can do in an organisation. So in Australia we have quite a number of laws that govern the way ICT works, in particular our privacy principles about what you can do with data and what you can't do with data. Next week we'll have a quick look at ideas about being responsible for that. An ICT professional also must be really good at problem solving, modelling, abstraction and design. And we've touched a little bit on that in the last few weeks. An ICT professional also needs to have an understanding of technology resources, even if they're not working in technology resources. So this is hardware, software, data information and all that. You've got to have an idea about how all that operates, which is our week 3 diagram, the whole of the ICT architecture. So we can't have somebody, we won't accredit a course which trains people to be ICT managers and they know nothing about hardware and software and ICT architectures. So if we have a course like that, and we do get them, where a person is said to be an ICT professional, we say, well, if they can't tell us about how computing works, then they're not ICT professionals. So no, we don't accredit the course. So they've got to know about tech resources, they've got to know about technology building, which is how you actually build or acquire systems, and they've got to know about how systems are actually managed and run, governance, ICT management and so on. So quite a comprehensive list of generic skills, as well as having all of those skills to do the technical work at their different levels and the disciplinary knowledge. So if you're working as a business analyst, you need to know quite a lot about information systems and about how they're constructed. That's that disciplinary knowledge. So quite a lot goes into this. And that's the other side of practice. So there's this skills, these technical skills that you need, and then there's all this generic and contextual skills that you need. And no matter which discipline you go into, whether it's marketing or international business or any of that, you have the same model, except they replace the technical skills with the various skills required to do those different sorts of roles. If you're going into a management role, you just take out the ICT skills and you stick in management skills, but the rest of it remains the same. So just about all professional societies are gradually coming closer and closer together to make sure that our top levels, this sort of stuff, is actually pretty well common across the different professions. This, of course, started with the medical profession a long time before ICT was even thought of. So that's the shape of practice, of doing things. Now, for the shape of the discipline, which is what we do, the teaching and research end of things. Building the knowledge base is what we try and do. So let's now separate out the discipline, the academic discipline, which is the rigorous study of things and the teaching of things, from the actual product development side of things. So ICT products are developed by organisations or by the military. They're not developed here in the university, generally speaking. We often trigger off innovations, technological constructions, but we don't actually do them. We generally, the university makes up a startup and gives the IP, the intellectual property to the startup, and then the startup runs with that, develops it, brings it up to a semi-professional or commercial level, and then generally gets taken over by someone who takes that IP and takes that development and actually puts it into production. That's a typical path for some idea that's created in a university. But most ICT is created by private enterprise and the military. And the military keeps their secret and uses it for competitive advantage until they no longer have a competitive advantage, and that's when they make it public. And so we have a GPS system here because the Americans decided that in 2000 they didn't need to keep this secret anymore, that other countries were going to get ahead of them very soon in GIS, so they made access to their satellites publicly available, where before it had been encrypted. So and now all of our phones work on location services thanks to the American military, who put those hundreds of satellites into the sky. Well, they did it for their own reasons, which were good reasons for a long time, and now the social benefit of that is apparent to all of us. So, the shape of the discipline, what we do here in the university. Well, what discipline is this actually? And that's always a conceptual problem. Many people call the discipline that I work in informatics. It's a European word, and it simply means the study of information and related ideas. So it was called information science at one point, but information science was snaffled by the librarians. So they think information science is theirs, and it's only about libraries. So in deference to them, informatics became a more common term. But it's a bit broken up, as we'll see. So basically the idea of information is that we study the nature of information, the creation of it, and the way information is deployed, particularly in organisations, but also in society. And it's based, this discipline is based in a whole set of theories about representation, the theory of representation, and that's what we were doing in week 1, about the idea that data represents something in the real world, that it's separate from something in the real world. That logic is separate from something in the real world, but it has effects on it because it causes actions to happen. So this idea of representation is the one that's underlying assignment 2, that you've got an electricity system that's generating electricity and consuming electricity. And on top of that, and separate from it, you've got your electricity information, which is measuring what's going on in that system and thinking about it and taking actions in that system. So this separation is really fundamental to understanding informatics. That you've got a physical world that's operating in a way, and you've got information, the information world, which is completely separate from it. And in between, there's you, thinking, world 2. So, representation. There are a lot of theories about information, about knowledge, about systems, computation, computer science and so on. communications theory, decision and problem-solving theories, how to go about doing problem-solving and undertaking decisions. And we've tackled a couple of ideas about technological innovation and organisation change earlier on today. So that's what informatics is. It's the study of these things. It's based in a whole set of theories, information-type theories. Its core practices are in systems construction and in systems usage by organisation and the globe. So we look at things and we build things and we analyse things. That's our practice, and that's what I was just talking about with the idea of what the industry is like and the practice and skills that people need. And the value, why do we bother with this? Well, we bother with this because it enables informed and knowledgeable action. Good information systems allow people to take actions which are more informed, that is, more data and information, and more knowledgeable, that is, the computer has supported them in their decision making. And you can see the links here between our work with data and our work with process modelling. The data modelling is a way of getting a database to deliver a whole lot more data and information to people making decisions. Process modelling, particularly causal loop diagrams and simulations, are great ways of improving the knowledgeable action rather than people taking ignorant action or doing what they've always done or just having a go. So that's the value of the informatics discipline, we hope. Here's a little graphic of basic and applied informatics. Basic informatics is things like computer science and technology studies, the way things are actually implemented in networks and so on, and systems theories. They're the three basic areas of informatics. There are lots of others. And the applied side, you just add E to things. So it's the way all of that stuff in red works with business as an applications area is e-business, e-education, e-health, e-government, e-society, and all the rest of it. So what we've got on the right is applied sciences, which takes a great deal of understanding of each of those bubbles and the way ICT and systems will actually interact with that industry. So e-government, for example, is very topical here in Canberra, needless to say, the home of government in Australia. And there are huge areas that sit at the intersection of government and systems. There's a department called I don't know what it's called now, DTA, Digital Transformation Authority it's called, the Digital Transformation Authority, which is all about how the government is going to adopt new technologies. The DTA is reasonably new, but there have been many organisations before it, just with different names, that did the same sort of work. So heaps going on with the application of ICT to government. Not always perfect, I've got to say. Now, this also is illegible, but it's there on your screens. The reason for putting up all this text is not to read it, but that this text just gives an idea of the scope of things, the scope of research. It comes from a journal called Advances in Intelligent Systems and Computing. I just want to list a few of the topics that it mentions. The topic spans all area of modern blah, 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 such as computational intelligence, soft computing, neural networks, fuzzy systems, evolutionary computing, social intelligence, ambience intelligence, computational neuroscience, artificial life, virtual worlds, cognitive science and systems, perception and vision, DNA and immune database systems, self-organising and adaptive systems, e-learning, teaching, human-centred and human, so on and so on and so on and so on, blah, 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 blah. Many, many, many different sub-areas of research in the informatics world. So it's big and it's complicated. thinking about research a bit more. Research is generally speaking divided into these two different camps: empirical research and non-empirical research. Empirical research is where you do laboratory work or where you run surveys, where you've got some phenomenon in the physical world that you're actually going to collect data about. Non-empirical work is speculative work, work about the humanities and history and logic and mathematics, non-empirical type work. And these two camps work unhappily together. Well, happily and sometimes unhappily other times. We use research for research results, that is, research papers, for three different purposes. The first one is to analyse things. So descriptive research tries to capture what's going on in a particular domain, to analyse it. And this is basically what you're doing in assignment 1. You're trying to build up a conceptual framework, a way of looking at a particular knowledge domain. The second level is explanation. It tries to explain what's going on. So instead of just identifying various parts of the topic, it now tries to relate them all together, to explain one result over another. And that example I used of the technology acceptance model, trying to explain when technology was being accepted, is a piece of empirical work at the explanation level. Prediction is when we try and predict what's going to happen in the future as a result of knowing what's happening now. And prediction is a different level to explanation. Take, for example, earthquakes. We can explain earthquakes. That is, the one that happened off Indonesia, Aceh, a few years ago. The explanation for this was that there are tectonic plates. One was riding over the other, and as the pressure built up and built up and built up, so there was a release, a tipping point, and boom, up came the plate, causing this tsunami, which did heaps of damage in all sorts of different directions. So we can explain that. We can account for how it happened in the past. But we can't predict them because we don't have enough knowledge to be able to tell when the plate is actually going to move. These plates are stuck one over the other and the pressure is building up, but we cannot yet measure, we cannot predict when that tipping point will be. So prediction is a different category to explanation. Explanation is something that's happened in the past, prediction something in the future. We use prediction a lot. I mean, all of our economies run on econometric models. So the government is sitting there with these models running about how the economy is ticking over and says, if I do this, maybe interest rates will drop. And so it takes an action that maybe will have an effect on interest rates. So it actually plays with its models to try and determine what's going on. The models have been built on the past, and so it's predicting what's going to happen in the future based on knowledge of the past. Unfortunately, those models are, while they've been in development for 40 years, they're a long way from being perfect. The systems don't actually operate according to the model. So the applied sciences, things like the professions, they use the work of scientists, they deploy that work. And so if you think about AusVIT, that little system that we were talking about last week, it sits in the applied sciences area because it uses research from these other areas and it deploys them in the field, so it applies them. And down the bottom, I've just put a whole bunch of text about just about an approach to research in ICT. The purpose of this is just to give a bit more background to what the nature of research is like and how it's actually used in industry. So what makes good research? Well, good research is pretty unpredictable at the beginning. You'd never know quite what's going to come out of it. And even if something interesting does come out of it, some theory that comes out from the research about how the world works, it may not actually have much impact. So last week I spoke about the problems that the funders had funding research into grapevines. Well, this is the other side of the story. This is the quality of a research output. Research output is always some theoretical proposition that something now exists, some way of thinking about something. And here are the general ways of looking at whether research quality is good, bad or indifferent. We look at its soundness, has it been well built? We look at its contribution, does it contribute to our understanding? It looks at the impact, how will my work allow people to act in a more knowledgeable and well-informed manner? And we look at whether or not it was ethically conducted. So given that, we can judge the quality of a paper and determine whether it's going to be published or not. I spent a good number of years as the editor of this Australasian Journal of Information Systems, and these are the kinds of criteria that we took into account when deciding whether to publish or not. One of the, we're almost finished this, one of the big pushes in information systems over the last 20 years has been this, it's design science. Design is a really strange activity. How people do it has been the subject of quite a lot of research. Next week we'll talk a bit about design science and design thinking. This is just to finalise this idea about research. This is what has been proposed by Hevner. Hevner is an American, but the other leading light in design science work is Shirley Gregor here at the ANU, who's a wonderful researcher. She and Hevner have done a lot of work together. And what they're saying here is that descriptive knowledge, knowledge of how things actually operate, and prescriptive knowledge, that is how to go about doing things, are related. We need to find a way of relating description and prescription. And they say that descriptive knowledge drives prescriptive knowledge, and prescriptive knowledge in reverse informs what happens in the descriptive knowledge. So it's got this loop happening. And they say that design theory fits then. It's a theory about how predictive knowledge actually works based on what our current understanding of a system is. Now, I don't think much of this myself, and next week we'll have a quick look at design thinking as well. But just to introduce it, design thinking is about the complex area or human activity of producing a design, and it's a very interesting and important topic for us, because that's what we do all the time, as you are with assignment 1. Good. So in this very brief talk, what I wanted to do was to give the context around the work that we've been doing on the technical stuff, that is assignment 2 and its application, and in the conceptual stuff, that's assignment 1. So the context is what I've tried to skip through today, the professional and academic context supported by those theories of tech change and organisations. So, that's all for presentation stuff. Now it's teamwork, and I'm here to talk with you about your assignment 1, which is due. When's assignment 1 due? Oh yeah, this Friday at 11:55.
油是冰。 他
exactly what you should be doing.
It's exactly what you should be doing. Yes, well done.
Well, it seems like we are already taught evidence-based management, but when I relook this process, I don't feel an evidence-based.
Yes,
That's
you
my
are.
conclusion.
Look at this. So you started to do your research on cyber security, and you found computer security, a concept, and you found another concept which was
Was information security. And the wiki said they are all the same, but I think some researchers think they are different, and
Yep.
some think they are the same.
And what was the third?
Cybersecurity.
Well, let's leave that one because that's the one that's our target, isn't it? Cyber
Yes,
security.
yes.
So you say no. Computer security has these different other concepts that are related to it. Some of these are also related to information security, but information security also has those. So these are the ones that are in common. So now, you say, what's cyber security? Well, cyber security, we've got a definition of cyber security, and some people say that it's everything. So one person says cyber security is this,
Yes.
and it's not separate, it's just cyber. And other people say that it's something different. So now what you're doing is you're saying, well, okay, what do I think? What do I think? I think that this has got to do with information, and this has got to do with computation, and they have some things in common, but they're not the same. So I'm going to use this definition of cyber to mean all of this, the whole lot. So here I've got a concept map. This could be a concept map for your assignment. My definition of cyber is that it embraces all of these things. Because you've done your analysis, you said, I've got 5 papers that have identified these components of there, I've got 3 papers that have identified those. I've mapped them, and I see that these are the same, they're talking about the same thing. But this is talking about people and human systems or something, which doesn't belong to, what? You don't want to include that in cyber? Then you have to draw your line like this. And so I'm going to use this because these are not related to virtual, the idea of being virtual. Right, so you might have this. With these things in common.
And something that is
Cyber,
it's
separate.
unique for information security or computer security.
Yep. And what about cyber? You've got some unique things as well?
Yes, and cyber, yes.
You think we're going to look something like that?
Yes.
Terrific.
So
That's fine. That's good. That's your work.
well, yeah.
That's excellent.
So
And you've got references to support this, references to support that, references to support that, and you've done your analysis to demonstrate these links.
well, another conceptual matter, and I think is about that cybersecurity from level
Yes.
Thank you. And like cybersecurity, and it's part of made by defense and threat.
Right, yeah. Mm-hmm.
And defense got this, and it's used and the cybersecurity is used the defense to face the threat. It's from the security perspective.
Ah, okay.
To
Yep.
use defense to face the
Good,
threat.
that's a
and
separate
all.
concept now. Because these are components. That is a component of this. This is a component of that, and it's also a component of that. So I should have actually been a bit more careful. Components, they're components or facets. But this relationship is different. This is a use. A threat is defended by or something like that. So there's something different. These relationships are different to those relationships. So you've got to just be careful about what the relationships are.
Should I put them in one concept or
No,
make
no,
two
quite
different perspectives?
Yeah, exactly. So you could have the use of that and the use of this, and you could find but those uses are different for some reason. You might find that. And so in your diagram here, one of the things that are in common, you might say, okay, well, what I'm doing is I'm bringing this and this together. Now the diagram's getting messy. And this is the uses of cyber security. And I'm taking some things from here, the defence stuff, on the inner side, and I'm taking some things from here, which is the threats. Who has threats, hackers and whatever. And I'm going to have another diagram. And here you might actually use a diagram from the cyber security literature, because they've got good diagrams about different sorts of threats and different sorts of assets here, like your assets. Assets. Like here is your data, that's an asset. You don't want people feeding your data, you don't want people changing your data, and there are other assets, information assets, your programs, I think. Anyway, don't worry, there are a number of different assets on this side, and cyber security is about defending against all these different sorts of threats. So you might use a diagram or something like that, rather than a diagram that looks like a concept. And you find lots of these diagrams in the literature that might catch that idea of assets and threats. That's not like it. An asset and a threat, you might find a diagram like that that's more useful than a diagram like that. But this is certainly very good for what you've used it for, which is getting the concept straight, figuring out what you're going to do. So I'm going to talk about this, and this, and this, and this. I'm not going to talk about the rest. So that's good. What you've done is good.
Yeah. So when we look at that time, I was confused how to balance my mind and the evidence.
Right. Well, just think about a courtroom.
What's my role?
Yeah. Think about a courtroom. Like in a courtroom, you've got the judge, and the prosecution presents evidence to the judge. Yeah. And the defence, they present evidence that tries to refute the evidence. Now what the judge is doing is thinking and weighing up the different evidence and coming to some conclusion. That's exactly what you're doing. You've got all the evidence, now you're weighing it all up and deciding what you are going to do with it. Evidence-based just means that there is something behind your thinking. You can account for where it comes from. That's what the evidence is. The evidence doesn't replace you. The evidence is simply providing you with reliable information for you to do your essential work. So that's what you're doing. Excellent.
And what I'm going to say, well, in my draft, this chapter of my draft, I saw the introduction, the backgrounds, and the concepts, and the literature review, and then I'm going to make a subunit of this computer science, security and information.
Yeah.
And
I'd start there. I wouldn't go for a literature review.
No, just from come to explain this with the literature.
Yeah, exactly.
And
I've done my research, and that's what I've come up with. And see, you might list a bunch of papers with this research.
this and I like to I still search for some conceptual analysis methods, and it told me to build some constraints of this concept and the characteristics. Use the characteristics to build the constraints of this. I think it's supposed to be my first part, and the next part is about the example practical use.